are continuing with our special rates. You could work now. Okay. You will get a note packet that will include your notes and your practice for the next 2 or 3 lessons. You're welcome. 3, 2, 2. All right. So, starting out today, okay, and this is going to be a continuation of what we already know, okay. We are going to assume that our hypotenuse of these right triangles is 1, okay. So what I want you to do, if you need to have your notes from last class next to you, you can turn to where it kind of breaks down what 45, 45, 90, and 30, 60, 90 is, meaning their side lengths, okay? So what I want you to find, given that the hypotenuse for both are 1, I want you to find the side lengths of each, okay? For 45, 45, 90, and then 30, 60, 90, okay? Given that the hypotenuse is 1. Go ahead. If you need to, consult with someone next to you if you get stuck, but I want you to try it on your own first. Knowing with 45, 45, 90, okay, both side lengths are x, okay? Your hypotenuse is equal to x root 2. So you're setting up an equation in order to solve for x. So we have 1 equals x root 2. How do we get x by itself? Alina? Divide by root 2. So we have 1 over root 2. Can we have a radical in the denominator? No. How do we get rid of it? Go ahead, Ethan. We rationalize, so we multiply top and bottom by root 2. So we're left with root 2 over 2. That is both your side lengths, since they are the same. Okay? Your hypotenuse is 1, and both side lengths are root 2 over 2. Okay? So now moving on to 30, 60, 90, across from 30 is your x, across from 60 is your x root 3, and across from 90 is 2x. Okay? So we have 1 equals 2x. What does x equal? 1/2. Okay, so that's across from 30 is 1/2. What is 60? Coop? Okay, so with that, you are correct. A lot of you had this, which is correct. However, can we multiply those guys together? Yeah, this is over 1. So we have root 3 over 2. A lot of you had 1/2 root 3, which is awesome. But you just have to multiply those guys together to simplify. Okay? So across from 60 is root 3 over 2. All right? So now, we're going to find the following ratios using our triangles. Okay? So, we have the sine of 45. I'm just going to choose this angle. It really doesn't matter which one you choose. So the sine of 45, how do we find the sine? Jason. Opposite over hypotenuse, which is? Good. It will still be root 2 over 2. How about cosine? Alina? Which would be? Excellent. Okay. Since I'm choosing this 45, I could use the other one as well. Opposite, root 2 over 2 over 1, which is just root 2 over 2. Adjacent, root 2 over 2 over 1, which is just root 2 over 2. Okay? So now we're moving on to the 30, 60, 90. So for 30, the sine of 30 would be what, Mia? 1/2. The cosine of 30 would be what, Helena? √3/2. Okay. Now, if we move to the 60, okay, here's 60. What is my sine of 60? Coop? Good, √3/2. And what is my cosine of 60? Yeah, 1/2. Okay. So, knowing these values are the most important. Okay. Knowing these values and remembering these values are the most important because we are going to go deeper into trig today. All right. Today we are learning about the unit circle. Okay. We will be, and I think I showed you last time, completing this circle today. You'll see later. Okay. We will be looking at the unit circle today and filling it out from start to finish. Okay, it's a helpful way to find the trig ratios for multiples of 30, 45, and 60. So 30, 45, and 60, those angles are, you have to know. Okay, those are a must. All right, so think of a circle. You have a center, and then what else do you have? Typically, a radius, right? So for the unit circle, our radius is going to be 1, meaning our hypotenuse for everything is 1. Hence is why we did the 2 triangles above. Okay? So our radius is 1. Okay? Our hypotenuse is 1. Anytime we needed to find a missing side length, or when we're working with triangles, we use the Pythagorean theorem. Okay? Knowing that a squared plus b squared equals c squared. C meaning our hypotenuse, right? So now we are going to be graphing these triangles on the coordinate plane, okay? So on the coordinate plane xy, which we've been using all year. So instead of a and b, we are replacing it with x and y and replacing c with our radius. So we're just updating our equation in terms of x and y. So x squared plus y squared equals r squared, which is the equation of a circle, hence the unit circle. Okay? So the center of our unit circle always, it will not change. In geometry, you have moved your center. With the unit circle, it's staying at 0, 0, and our radius is at 1. Okay? So this is where the next part is where the color coding comes in. Okay? This has been helpful in years to kind of make connections with and using the same colors for the same triangles all the way around. Okay? So what I'm going, unless you have your own, you can turn the page. Okay? We are just going to recall what we just did. Okay? With our hypotenuse, which is now pretty soon going to be our radius. Okay? Our hypotenuse is 1. Okay? So for 45, 45, 90, our 2 side lengths were what? You can look back. What was our 2 side lengths? What did we just find? √2/2. Both side lengths were √2/2. Okay? Now, for our 30-degree angles, okay, for 30 degrees, what was opposite 30 degrees? What was that measurement? 1/2. Okay. What was across from 60? Okay. So we have 2 different triangles, however, same kind of measurements. We have our 30-degree angle. We have our 45, but now we have 60, which is going to be very similar to this. Okay. What did we say was across from 60? And across from 30? 1/2. So if you noticed, those two sides just switched, right? Okay. So each of these triangles, I want you to choose a different color. Okay. I'm going to use the highlighter tool up here. And for my 30 degrees, I'm just going to use this color. You guys outline or make it noticeable. Okay. So use your first color with your 30 degrees. Okay. Just kind of outline in that color. 45, use a different color. Okay. And 60, use your last color. Okay, make sure you could see. If you have to color it in a little bit more, you can. Just so you could see the differences in colors. Just the outline. Yep, just the outline so you could see it. Okay. Just so you could see the differences. My blue and turquoise. Blue is 30, green is 45, and my pink purple is 60. Okay. I'm going to use those colors throughout. So, these are what the triangles look like as is. Can you stop? Now we're going to see what these triangles look like on the coordinate plane. Okay, so use your first color. Okay, and we're making a 30-degree angle, which creates a right triangle. We're dropping a perpendicular line once it reaches the edge of the circle to create our 30-degree angle. Okay, and we're going to fill in what we have above. This is our 30 degrees. Okay. Across from it is 1/2. Adjacent is √3/2. Okay, so all we're doing is taking above and pasting it within the circle. Okay, we're going to do the same thing with 45 and 60. So take your next color, highlight the whole entire thing. This is 45, label the degrees as well. And we know this is √2/2, √2/2. Okay, I'm going to do the same thing for the last one. √3/2 and 1/2. Okay, so once you have those three triangles copied down, okay, I want you to think of a few things. One, if we were to just highlight that first line, okay, forget about the two sides, we're just highlighting this radius here, which, bless you, which we know creates a 30-degree angle. How would I take, knowing this is 30, how would I take both of those side lengths and write it as, I want to know the point of this circle, the point on this circle. How would I write it as an ordered pair? Think of it now, okay? What we're used to, points on a graph, right? We're given side lengths of a triangle. How would I take those side lengths and create an ordered pair? Jason? Okay, so how would I write it? Given my... 1/2, okay, do we agree? What do you guys think? Jason, thank you for that. Why? Yes, you are correct. So your horizontal just switched. okay? Your horizontal is your x, because remember, for ordered pairs, what is it written in?
Oh, X, Y.
It's okay. It's okay. XY, right? So we're taking our horizontal length, which is root 3 over 2, and our vertical length, which is up and down, is 1/2, and creating our ordered pair. Okay? So the point on that circle for 30 degrees is root 3 over 2 and 1/2. Okay? So now we move on to that middle line, which is 45 degrees. What would that point look like? Alina? Good. Root 2 over 2. Root 2 over 2. Okay. We're going to do the same thing for the third one. Okay, for 60 degrees, what would that coordinate? Liv. Excellent. Okay, so this is what it looks like individual. Okay, we have our 30, then 45, then 60. So now we're going to combine them into one picture. Okay, so you have right now your first quadrant. Okay, you have your first quadrant. So I want you to fill out, as we had above, your 30, your 45, and your 60 in your coordinates on the side. So use your colors again. Don't forget to fill out the degrees as well. And you could write them right on the line to help you. Okay, so with ordered pairs, no matter what, it's x and y. Okay, so looking, if we go back to our triangle, horizontal, right, going across this way is our x values. Up and down is always your vertical. So x, y. Okay, right? Yep. Well, I will. I was just explaining to her. Okay. So we filled out our 30, 45, and 60. Well, we have these two bookends here. Okay? We have these two bookends. Which would be what? What did we just create? What? 90. So the top should be what degree? No. What did we create? 90, right? So that's 90. What should this be? 0. Okay? So we have 90 up here, which I believe some of you said even within it. Okay? And then you have 0. Well, these are creating our intercepts, no? Right? This is an intercept. And that is 2. What would they be? Yeah. These are all degrees. Yeah. No. Okay? Yeah. For what? No. A little complicated. It's okay. It's okay. So think of, you have 0 and 90 here. They're going to be our x and y intercepts. Okay? Yeah, Jason. Why?
That's how long the radius is.
Yes, excellent. So here, right, is our radius. Here is our radius, right? So how would I write this as a point? Go ahead. Forget about 90 is just your degree. Think of your points. Mm-hmm. 0, 1. Okay. What would this intercept be? Yeah. 1, 0. Because your radius is 1 all the way around. Okay. So your x and y intercepts are 0 degrees and 90 degrees. Okay. 0 is 1, 0, which is your x-intercept. 90 is 0, 1, which is your y-intercept. Okay. So when you think of quadrant 1, both x and y are what? Positive, negative, negative, negative. What are they? They're all positive, right? So quadrant 1, x and y are both positive. So what will happen now if we move to quadrant 2? Liv? X is going to be negative. So let's turn the page. Oops. Okay. So right at the top, or somewhere, quadrant 2, negative x, positive y. Okay. So before we get to quadrant 2, I want you to fill out what we just did, quadrant 1. Okay. Using your colors, filling out the degrees, filling out the measurements. Okay. The coordinate points. Yes. Yep. All right. So once quadrant 1 is filled out, okay, what would my other x-intercept be? Jason? Okay, what would just this x-intercept be? What would that point be? Yeah, Lena. Negative 1, 0. And we know a circle is 360 degrees. So half a circle is what? 180. Okay. So you guys are correct saying that your x values will be negative. Well, how can we tell what's what? What would be blue? What would be green? What would be pink, according to mine? How can we tell that? What do we do? Okay. Okay. So which one would be blue if I did first, second, or third? First, okay. Second one would be green, and then the pink or purple, whatever the color it is. Okay? It looks pink on here, but I don't know. Anyway, so you are correct. You are referring to quadrant 1. They're similar angles on either side. So This one here would be the same as 30. However, your point would be negative root 3 over 2 and 1/2. Okay, then we have our green. Okay, so we have negative 3 over 2. Okay. So we have our coordinates. Okay. We have our coordinates. How can I figure out the degrees? So what would like the blue line be? Yeah. It's okay. Jason? No. Hold on, I see it. You have a right idea, just wrong second number. You have the right idea.
Wait, it's 180 on the left.
Uh-huh.
Is it 180 on the right as well, or is
No, it's 0. Need some help?
it?
Okay, Josh.
You would subtract 30 from 180.
In order to get what? 150. You said 0. You said 0.
Oh.
It's okay. So 180 minus the blue, which is 30. 180 minus 30 gives you 150. What would the green line be? 135. What would the pink line be? 120. Okay? So you're always using that x-axis, okay, to help you, never the y. Okay? Always the x-axis, never the y. So we have similar angles here. That's why we're able to the coordinate points just become negative. They're the same. Okay? So how can we find the angle measures in this quadrant? Okay? Take 180 minus either 30 or 45 or 60. Okay? We're referring to quadrant 1. How can we find the coordinates along the unit circle? Along the circle. We know they're negative x and positive y. And we're using similar angles. Okay. And our new x-intercept is negative 1, 0 at 180 degrees. Okay? So now, if we move to quadrant 3, what's going to be different? Y is going to be negative as well. So x and y are both negative in quadrant 3. Okay? So go ahead and fill out quadrant 1, quadrant 2. You can start quadrant 3, but I would be careful. Okay? Yes. Hold on one second. Yep. Okay? For quadrant 3, negative, negative. Yeah. Okay. The degrees are always going to be positive that we're going to see.
Yeah, but like it's kind of going, like it's getting more positive. It's like counterclockwise.
I get what you mean. Yeah. Oops. should be filling this out. Quadrant 1 and 2, we should be filling out. It's a lot of repetition. Okay. So, quadrant 1 and 2. Good. All right. What would be our new intercept here? Yeah, Jason.
Wait, are you asking for like
The point. The point.
0, -1?
Good. Okay. Anybody know what the degree would be? Go ahead. Yep. Okay. So now, it's 270 because it's 180 plus another 90. Okay? So, how can we figure out what's going to be blue, green, or pink? Go ahead, Coop.
Said that
Mm-hmm. Careful. Careful. It would be the other way around. Okay? The reason is, and I'm really glad actually you said that. Okay? The reason is that is the biggest mistake that happens because we tend to switch because they're so similar. We tend to switch those two. But you always want to go from the x-axis, never the y. Okay? So from here, and also if you go from quadrant 1 to 3, if you follow this line, it's going to be the same. Okay? So this first line here is blue. $180 plus another $90. Okay. Okay. Yeah. I mean, this is piecemeal together, but on a regular, if you look at the last one of the pages we have here, like this one, they're all connected. Yeah. Okay. They're all connected. So if you go from quadrant 1 and follow that line across, you're going to get the same thing. Can someone tell me what the degree would be here for blue, Kat? Careful, not 240. It's okay. So what is the, from here to here, this blue line represents what? 30, 45, or 60? 30. So if I add 30 to this, 210. Good. 210, and I would have negative root 3 over 2 and negative 1/2. What would be my next degree? Go ahead, Alina. 225. 45. You add 45 to 180. Okay. And then after 225 would now be what? Go ahead, Alina. 240. So, when you're in the third quadrant, you add now your degrees, okay? So 180 plus 30 gives you 210. 180 plus 45 gives you 225. 180 plus 240 plus 60 gives you 240. Okay? So our new y-intercept is 0, negative 1, and it's 270 degrees. All right, almost there. The last one now. Quadrant 4 would be what?
X's would be positive and Y's would be negative.
Good. So go ahead and start filling out 1, 2, and 3. You may start 4, but again, be careful. Okay? I know. I know. Okay.
I can reasonably assume that there will only be like one of these questions on the test.
But you will get a blank unit circle every day. Every class, you will be filling out a blank unit circle. Yep. And we're not done with the unit circle either. We're adding to it eventually. Yes, there is. Always more. You haven't learned that by now? We're in May.
I know.
Oops. Jeez. He's funny. James, don't worry. And I'm recording. Don't worry about it. James, Emily. Don't worry, you guys. Okay. So, it's okay. I'm going to just talk as you guys write. Okay? As you fill out the unit circle, we know a full circle is how many degrees? 360. And that's where we end. 360 and 0 will have the same coordinate point, the same x-intercept, okay? Which is 1, 0. Yep. God bless you. Okay, so this is x, here's y. Okay, in quadrant 4, x is positive, y is negative. Okay. All right. So, as you guys are still, I'm going to be talking just to get this through because it is shortened a little bit today. So, looking at these lines, 1, 2, and 3, out of those 3, which one will be blue? Cool. Nice job. Okay. The one closest to the 360. Okay. Then we would have our green, then our purple or pink, whatever it is. Okay. So we would have root 3 over 2, negative 1/2, root 2 over 2, negative root 2 over 2, 1/2, negative root 3 over 2. So one thing about the blue and purple, okay, those, I see it more in the 4th quadrant than I do the 3rd. The coordinate the degrees might be the same, like be correct, but these are always switched for some reason, okay? Just remember you're always going from the x-axis. So let's finish up the degrees, okay? The blue line is going to be what? 330, good. Oop. Green, careful. 315, it's going in the opposite direction, so, and then 300. Okay, so you guys completed the unit circle. However, all we really need to know is what quadrant? One, right? To fill out the rest and know the signs, obviously. Okay, the first quadrant is your go-to. Okay, if you know and understand quadrant 1, you will be able to fill out this whole entire unit circle. So this is, what does it look like to you, first of all? Nope, 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 nope. Think of in your head, this is 0, okay? So that's where you're it's not starting at the bottom, it's starting here. I want you to think of something that most of you might have been on. Bingo, okay? Because which way does the Ferris wheel typically go? All the way around. Most go counter as you get on here. So as you get on there, it resembles a Ferris wheel. We will be using the unit circle for A, to find exact values, okay, number 1, okay, of sine, cosine, tangent. We will be graphing using this, okay, and if there's time, we will get into applications, which is the biggie in terms of word problems. We look at trig functions for tides, okay, for waves, for Ferris wheels, okay. All of this you will see. Those of you continuing on to pre-cal next year will be doing this a lot, okay? So a lot. A lot. You're welcome. So your homework will be, and some of you are still filling out, I just want you to know, there's also tricks to fill out the unit circle, but I'm not going to tell you any until some of you might come up with them on your own, number 1. Number 2, I will show you some tricks eventually. But after the first few times of you filling out a blank unit circle, I want you to discover your own pattern, okay? There's plenty to come up with, okay? There's plenty. There's also, to fill out, if you notice at the bottom, I will in 1 second, a bow tie method. Refer to your notes. Same thing, okay? The bow tie method, right? Which is, if you look at the blue lines and green, if you drew the lines down, they're the same, making your bow tie, okay? So your homework will be to fill out, if you look at the next page, it's the blank unit circle. I want you to try to do this from memory, okay? The best you can, okay? Especially that first quadrant. If you need help for the rest, go right ahead. But, no. Yes, Jason. Everything. The radius is always 1 for the unit circle, okay? So it will never change. Those 2, you got to fill out all. No, you're not given anything. You know that first quadrant. You found that at the beginning. It's okay. Yes, of course. Yeah, nothing is changing. No. Mm-mm. On the unit circle, no. Yeah, Coop. Coop. So, your homework is the blank unit circle. Then eventually, and probably during next period, it's going to be a very short delta math. Okay, very short. It's on our special rights. It is on finding angles. It's very short, just to kind of keep that fresh in your mind. Okay, so blank unit circle and then a short delta math. All right, that would be your homework. And then Friday, we will continue. When you come in, you will be given a blank unit circle. Okay? Yes, it will be.